Good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy. And if you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. Our lesson for today is all about second quarter, module 4, or simplifying radical expression with perfect nth root. Okay, before we go directly with our lesson, let's try to recall first how to transform fractional exponent to radical form and simplify if possible. For example, number 1, we have 32 raised to 2 all over 5. We can transform this to radical form by simply first copy the base and place it inside the radical sign. So that is 32. Next, we copy the numerator part of the fractional exponent and serve it as the power, and the denominator part will serve as the base or the degree of the radical. So, our answer now is fifth root of 32 raised to the second power. Notice that fifth root of 32 can still be reduced and simplified into fifth root of 2 raised to 5. By prime factorization, that's 2 times 16, then 16 times 2, and so on. It's simply fifth root of 2 raised to 5 raised to the second power. Notice that the power and also the index are the same, so we can cancel them out, and what is left is only 2 raised to the second power. So 2 squared is now equal to 4. Okay, there you have it. Our answer in number 1, 32 raised to 2 fifths, is simply 4. Okay, let's try to answer number 2. In example number 2, we can simply rewrite this in radical form. That is simply, again, copy the base and place it inside the radical sign. Then we have here the numerator part will serve as the power and the denominator part will serve as the index. Here, so the index is 4, which is the um, order of our radical, and this is 1. So our answer now is simply fourth root of x. And example number 3, since they have the same index, we can rewrite them as 1. So that is fifth root of copy our base, which is x raised to 3, y raised to 2. And for our example number 4, since this is enclosed in a parenthesis, that means they are considered as one term. So if we will write this in radical form, that is simply square root of the quantity x minus 1, wherein the power is 1 and the index is 2. Then we know by convention that the lowest index is 2, so we can rewrite it only as square root of x minus 1, or simply square root of x minus 1. And lastly, number 5, we can only transform fractional exponent into radical form. Since that is 7x raised to 1 half, we will just copy 7. So 7, then copy the base of x raised to 1 half, that's x, and then this is 2, this is 1. So our answer now is 7 square root of x. Last week, we also discussed how to transform radical form into exponential form. So let's try to answer these 3 simple problems. So if we're going to transform cube root of x into exponential form, first is we copy the base again, and then the exponent here is 1, so this will serve as your numerator part of the fractional exponent. So that's 1 all over. The index here will serve as your denominator of the fractional exponent. So the answer is x raised to 1/3. In example number 2, notice that the square root has a lowest index of 2, or the index here is 2. If we will rewrite this in exponential form, the answer is x raised to 3 all over 2. And for last example, we can rewrite this as the quantity of x raised to 3, y raised to 5, raised to 1 all over 4. And we can also distribute the exponents. So that is by applying power of product. So that's 3 all over 4. So x raised to 3 all over 4, y raised to 5 all over 4. Okay, so these are the answers on how to transform radical form to exponential form. I hope that you already recalled our past lesson. This time, the topic that I'm going to discuss is all about simplifying radical expressions with perfect nth root. The knowledge you have in transforming radical form to exponential form and vice versa will help you in simplifying radical expressions. Let's go. Okay, radicals are said to be in simplified form if number 1, no fractions left under the radicals. Number 2, no perfect power factors under the radicals. Number 3, no exponents under the radical greater than the index value. And number 4, no radicals appearing in the denominator of a fractional answer. So if we're going to simplify 9 raised to 1 half, we can express this in radical form. So 9 raised to 1 half is the same as square root of 9. We know that square root of 9 is equal to 3. The same with letter B. If we will simplify this is simply fourth root of 16. Then, to simplify, we do prime factorization. That's 4 times 4. This is 2 times 2. Also, this one, 2 times 2. So, we can write 16 in terms of 2. So, that's fourth root of 2 raised to 4. So 1, 2, 3, 4. So that's 2 raised to 4. Again, since the index and the power are the same, we can cancel them out. The answer now is simply 2. In our example or letter C, we can also express this in radical form. That is simply cube root of 27 raised to the second power. So again, we can simplify cube root of 27, applying prime factorization. So this is now the same as cube root of 3 raised to 3 raised to the second power. Since the index and the power are the same, we can cancel them out. What is left is 3 raised to the second power, and the answer is 9. Let's have some more examples. Let's say we're going to simplify 100 raised to negative 1 half. So in this problem, in order for us to simplify this, we'll make first the negative exponent into positive integral exponent. So if we're going to make this positive exponent, we simply get the reciprocal. So that's 1 all over 100 raised to 1 half. Then, we transform now 100 raised to 1 half in terms of radical form. So that's 1 all over square root of 100. And we know that 1 all over square root of 100, the answer is 1 all over 10. For next one, first is we transform this to radical form. That is simply fourth root of 16 raised to the third power. Also this one, we have cube root of 8 raised to the fourth power. We can express 16 in terms of 2 raised to 4. So that's 4. Fourth root of 2 raised to 4 raised to the third power. And 8 can be expressed in terms of cube root of 2 raised to 3 raised to the fourth power. So we can simplify this. What is left is 2 raised to the third power multiplied to 2 raised to the fourth power. So cancel this out. And apply law of product. So if you still remember in law of product, so to multiply exponent having the same base, we just simply copy the base and add the exponent. So 3 plus 4 is 7. And we can evaluate 2 raised to 7. That means 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 and times 2, 128. So 2 raised to 7 here is simply 128. And for our last example, if we're going to get the quantity of negative 64 raised to 1/3, we can rewrite it as cube root of negative 64. So there is a rule in getting the root of odd index and even index. So here, if our index is odd and the radicand is negative, the answer is negative. If the index is even and the radicand is negative, the answer is no real solution. Since our index is our index is odd and the radicand is negative, therefore we have an answer and that is negative. So we can write this as cube root of negative 4 raised to the third power. So negative 4 times negative 4 is positive 16 times negative 4, the answer is negative 64. So again, we apply. Since the index and the power are the same, so that's cancelled out. What is left is only negative 4. Okay, Our next slide is about the laws of exponent can be applied to obtain products and quotient of expression containing rational exponent. So if you still remember the product law of exponent, that is x raised to m times x raised to n, that is equal to x raised to m plus n. So in our example, letter A, if we're going to apply product law of exponent, that is simply copy the base, which is 36, then we add the exponent. 1/4 plus 1/4, and the answer is 36 raised to 2 all over 4, or simply 36 raised to 1 half. If that is raised to 1 half, we can transform 36 raised to 1 half into radical form, that is square root of 36. And we know that square root of 36 is equal to 6. So the answer here is simply 6. The same goes with example letter B. So that is 9 raised to 1 half plus 1 half. That is 9 raised to 2 all over 2. And 2 all over 2, that is simply 9. 9 raised to 1 is equal to 9. Okay? So that's how you apply law of exponent in containing rational exponents. We can also apply quotient law in fractional exponent. So if you still remember quotient law, that's x raised to m all over x raised to n is equal to x raised to n minus n. So in our example number 1, we can solve this as 81 raised to 3/4 minus 1 half. So first is we get the LCD, so that's 81. That's 4 and 2. The LCD is 4. So 4 divided by 4 is 1 times 3. So that's 3. 4 divided by 2 is 2 times 1. So minus 2. So simplify it. We have 81 raised to 1/4. Then we can now write this in radical form. That is simply 4th root of 81. And if you still remember 4th root of 81, that is simply 4th root of 3 raised to 4. Then we can cancel them out. So the answer here is simply 3. In our next example, that is 8 raised to 2/3 minus 1/3. Since the fractions are similar fraction, so we subtract the numerator and copy the denominator. So the answer here is 8 raised to 2 minus 1. That's 1 all over 3. Then transform this to radical form. That's now cube root of 8. So cube root of 8 can be expressed in terms of 2 raised to 3. So cube root of 8 is the same as cube root of 2 raised to the third power. Since again the index and the power are the same, we can cancel them out. The answer is simply 2. And lastly, if we have 15 raised to 3/4 all over 15 raised to 3/4, so that is 15 raised to 3/4 minus 3/4. The answer is 15 raised to 0. So remember that any number raised to the power of 0 is equal to 1. So the answer here is simply 1. Okay, so that ends our lesson for today. I hope you learned something new and see you soon. Goodbye.